Hi, myself Dr. J. Glory, Associate Professor of Physics, Institute of Aeronautical Engineering. Today I wish to tell about the fabrication of nanomaterials, solid gel method. So already we discussed about the different approaches in the fabrication of nanoparticles. That is, we have a top-down approach and then bottom-up approach. So as we know that top-down approach is the getting nanoparticles from the bulk size. So bulk size is reduced and reduced and reduced to the nanoparticle size. In the second case, bottom-up approach, so atom by atom build it up into nanoparticle size. So that we are getting in two approaches that nanoparticles. We can fabricate nanoparticles in two ways, top-down and also as bottom-up approach. So, and also we have discussed about the methods which are under this approaches. So here a bottom-up approach. So in this bottom-up approach, so here there is a group of atoms or so they build up atom by atom, individual atoms they are built up and we can make it clusters. Then this will build up and we can get the nanoparticles, that is desired nanomaterials. So let's go to the introduction about the sol gel process. The sol gel process is known since long time, so that is in 1800s. So this technique is rediscovered in the early 1970s. So again it is rediscovered in the early 1970s when glasses were produced without high temperature melting process. This method have also been used extensively. Sol gel is a chemical solution process used to make ceramics and glass materials in the form of thin films, fibers or powders. So the sol gel is a chemical solution process. Sol gel is a chemical solution process. This sol gel process is used to make ceramics and glass materials, fibers, thin fibers, powders. So sol gel. So before going to the sol gel, we should know about the colloidal particles. So the colloidal particles are much larger than the normal molecules or nanoparticles. So if we take a colloidal particles, so in this colloidal particles, colloid is a mixture. It is a mixture. So as colloidal particles are much larger than the normal molecules or particles. But when coming to the colloid, a colloid is a mixture in which one substance consisting of microscopically dispersed insoluble particles is suspended throughout another substance. So there is a solute and then solvent. So if the solute is solved in the solvent, then the solution will be formed as a clear and it has been mixed up well so that no particles will be left over as undissolved. Okay. So but here in this case, a colloid is a mixture. So in which one substance consisting of microscopically dispersed insoluble particles and it is suspended throughout the another substance. So if we take a substance solute, substance 1, and this solute is another substance. Solute is another substance. So this solute is dispersed in this solvent and this solute does not dissolve in the solvent and it has been suspending in the solvent. So colloid is a dispersed particles suspended in the solvent. Okay. So a colloid is a mixture in which one substance consisting of microscopically dispersed insoluble particle and it is suspended throughout another substance. So that is colloid. So when mixing with a liquid, colloids appear bulky, whereas the nano-sized molecules always look clear. So the solution in which molecules of nanometer are disposed clear. The colloids in which molecules of size ranging from 20 nanometers to 100 nanometers appear milky. So a colloid suspended in a liquid is called a sol. What is sol? A colloid suspended in a liquid is called sol. A suspension that keeps its shape is called gel because of evaporation of fluidity in the solution. Because of evaporation of fluidity in the solution, it becomes a viscous nature. So that liquid have viscous nature. So it has some elasticity. So that type of liquid is gel. So it has some structure. So a suspension that keeps its shape is called gel. The sol gels are suspensions of colloids in liquids that keep their shape. Sol gel formation occurs in different stages. So initially a homogeneous solution of a material is prepared and used as a precursor for nanofabrication. So the sol is deposited on a suitable substrate by spraying, dipping, by spinning, and it is kept for a while for gelation. So first we are taking a solution. That solution have some colloid particles. So these colloid particles are suspended in the liquid. So after that, the sol is deposited on a suitable substrate. A substrate is like a base, so which is not reactive with the liquid which we are going to spin, dipping or spraying like that. So the sol is deposited on a suitable substrate. So here we are depositing the sol. So by spraying or dipping, so we can dip this sol, or else we can spin. We can spinning this. After that, we kept for a while to make a form of gel. Okay, so first initially we are taking a homogeneous solution material and we used as a precursor for nanofabrication. That sol is deposited on a suitable substrate by spraying or spinning or dipping. After that we kept for a while, then it become as a gelation form. So after keeping, that is keeping for a while, in the sense it has to come in the form of gelation. So meanwhile the fluidity of the liquid will be evaporated, so it get viscous form. So during this gelation time, the material gradually loses its fluidity and undergoes a transition from viscous liquid state to elastic solid state. So this gelation time depends upon the liquid viscosity, temperature, etc. So this process can be characterized by distinct steps. So let us see the distinct steps involved in the sol gel process. So hydrolysis. So the different steps in the sol gel process: hydrolysis, condensation, aging and drying. So the desired colloidal particles are dispersed in a liquid to form a sol. The deposition of the solution on the substrate by spraying, dipping or spinning. Then the particle in the salt are polymerized through the removal of the stabilizing components and produce a gel. So it makes some network. So in this condensation, the particles in the salt are polymerized throughout the removal of the stabilizing components and it produces a gel. In this aging and drying, the final heat treatment spirals the remaining organic and inorganic components and form an amorphous or crystalline nanoparticles coating on the substrate. So after that, we are drying this one by through the heat or air, we can get our designed crystalline nanoparticles coating on the substrate. So the main benefits of salt gel process are the high purity and uniform nanostructure. We can get high purity and uniform nanostructure achievable at low temperatures. Can be achievable at low temperatures. It normally used to produce metal oxide nanomaterials. So this is the diagram of salt gel method. So here we are here there is a solution of precursor. So through the condensation, so we are getting salt, that is colloid particles are suspending in the liquid. Then after the gelation time, so fluidity will be losses. So fluidity will be evaporated and it gets gel form. It gets gel form. So after that, keeping this dry, make this into dry. So if we dry in the presence of air, we get aerosol. If we dry it in the presence of temperature, then we can get a xerosol. So after drying this, we can make a powder that gives the nano particles. So here the salt can be sprayed on the substrate. This is the substrate. This is the substrate. So the salt is spraying on this like a coat, so that we can get, after drying this, we can get a dense thin film. We can get a dense thin film. So in another way, we can get a fibers, and in another side, if we dry this one, we can get a fine powder of nanoparticles. So solution of precursors, after condensation, we have a salt which is mixed with the colloid. After the gelation time, so the fluidity will be losses, so that we'll get a form of gelation, form of gelation. So this can be dried. This can be dried and get the powder. So in xerosol, we can produce dense ceramics. We can produce dense ceramics. So likewise, we can produce nanoparticles by the salt gel method. So what are the advantages of this salt gel technique? So it can be produced a thin bond coating to provide excellent adhesion between the metallic substrate and the top coat. It can be provide thick coating to provide corrosion protection performance. And it can be easily shape the materials into complex geometries in a gel state. It can be produce high purity products because the organometallic precursors of the desired ceramic oxides can be mixed, dissolved in a specified solvent and hydrolyzed into a salt, and subsequently a gel The composition can be highly controllable. And there is a possibility of synthesizing nanometallic like glasses, glass ceramics, or ceramic materials at very low temperatures. And in general, the advantages are it can be able to get uniform and small sized powder. It can get low temperature, high density glass without high temperature recrystallization. Can get new composition of glass, easy to do coating for films, and also we can get fibers. So in the same way, we have some disadvantages along with advantages. So the disadvantages of sol gel technique is controlling the growth of the particle is difficult. Controlling the growth of the particle is difficult. Stopping the newly formed particles from agglomeration is also difficult. Then coming to the references, so the textbooks, Engineering Physics by Mr. K. Tyagarajan, McGill Education Private Limited, New Delhi, a textbook of Engineering Physics by Mr. M. N. Avdhanlu, P.G. Shirsagar, S. Chandan Company, New Delhi. Engineering Physics by Dr. M. Armugam, Anuradha Publications, Chennai. Engineering Physics by P.K. Palanisamy, 4th edition, Scientific Publications, Chennai, 6,70,000. Engineering Physics by Dr. K. Vijay Kumar, S. Chandan Company, Private Limited, New Delhi. So these are the reference textbooks to this topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.